Hello, dear students. I'm Samir Velankar. I welcome all of you to this another video on B plus tree. Just in the previous video, we created a B plus tree of order 4 using data 1 to 15. And this is the B plus tree we got. Now, what's the advantage of B plus tree as far as databases is concerned? Now, actually, if you look at this B plus tree, these numbers 9, 3, 6, 12, and all these funny numbers that we have stored are actually called as record key or primary key or index key in the database management system. Listen, if you are not understanding this till you listen to this, because you will note all this, again, you will go through this in DBMS, the subject called DB. But then all these 9, 12, 3, 6 are called record primary keys or index keys. Many times these are called search keys also. Now just imagine this 9, 3, 6, 12, 1, 2, 3, all these numbers are roll number of the students. So what we have, we have in our application, we have a student database, okay? We have a student database, and the student is a table actually. It's a table of records where we have stored roll number of the student, name of the student, and maybe marks scored by the student in the test. So this is a very simple table which contains data of many students. Let's say roll number is 1, roll number is 2, and there are such 15 students. So we have a table which stores roll numbers 1 to 15 and their names, whatever ABC name. Let's go for arbitrary names, DEF, XYZ. All these are names and marks scored. Maybe these are the marks scored. So we have a table called student, okay, and we have so many records. This is called a student table. Now this student table is stored, but then after storing the student table, the big point is we want we want to actually search the records. Basically, databases are always searched, isn't it? Now, to make the searching faster, what is done is on this student table, one index is made, index. And the B plus tree that we have created here is basically index for that table. Index for student table we have created. And the index is made on roll number key. Now, index can be made on any key. So somebody will say, no, don't store 9, 3, 6, 12, all this in the node, but instead store names. So ABC, DEF, these names will be stored inside the node. And then we will say B plus tree is nothing but an index. It's an index made on basically names, isn't it? Okay. But we have made the index on roll number. So what am I up to? You please try to understand. What are we trying to learn? Now we have stored roll numbers. We have stored roll numbers in the B plus tree. But what about name and marks? Now these leaf nodes of the B plus tree, listen carefully. These leaf nodes of the B plus tree, have pointers. Left pointer of 1, then pointer in between 1 and 2, pointer in between 2 and 3, isn't it? And next pointer of 3 will of course point to the next leaf, correct? Now these pointers will point to the actual record. So we will have ABC here and 99. Note that roll number 1, according to us, roll number 1 of our class, it has name ABC and marks 99. Now there is 2, roll number 2 has the name DEF and marks are 100. Like that, 3, the pointer for 3 will point to the name and marks of roll number 3. Similarly, 4 here has a pointer, 5 has a pointer, 6 has a pointer. All these pointers will point to records. isn't it so? So suppose you just imagine all these pointers in the leaf point to their records. So imagine in the database management system, we write a query like this. We write a query and we tell our DBMS give or tell us give record for roll number equal to 9, suppose. So what you will do, I mean what DBMS does is that it starts searching 9, this index, isn't it? And it gets 9 right at the root. Good news. It gets 9 at the root, no doubt. But it continues its search till the leaf. Although 9 is found in the root, it will now search 9 to the left of 9 because 9 should be stored again to the left of 9 and then to the right of 6. And once it reaches the leaf where 9 is stored, observe 9 is stored, it will use the pointer of 9 and it will get the name, whatever is the name, LMN, and the marks of 9. That's how record can be easily fetched for any student based on the roll number. So typically, we write SQL query as select star from student where roll number is equal to 9. And just imagine that we have 1000 records. Then searching one student with roll number 9 is going to be time taking, isn't it? So what DBMS does is it creates an index. Of course, we have to create an index by giving a command, but it creates an index on roll numbers. So roll number search will be very fast because this is a fat tree with less depth. So searching will be very fast. 9 is searched, fetching very few nodes. 9 is searched very fast, and we get the record. So B plus trees are basically meant for giving optimal performance on search. One very good thing you observe again. Suppose we say DBMS, please give records for roll numbers between 9 and 12 and 13, let's say, including both 9 and 13. This is called range query in DBMS. We write select star from student where roll number is between word is there in SQL, where roll number between 9 and 13. So how will our search begin? DBMS will search root first, and right there it gets 9, isn't it? So 9 is there, but it will continue the search. It will visit left because 9 is stored again to the left of 9. Then it will visit right of 6. It will reach the leaf which stores 9. And then using pointer of 9, it will get record of 9, LMN and 65. But that was not our problem. We wanted 9 and higher than 9 also. So what? We have a pointer here. Look at that. We have a pointer pointing to the next leaf, isn't it? And it will fetch record of 10. Record of 10 can be fetched by using the pointer of 10. Record of 11, similarly record of 12, and using next pointer again, it will enter this leaf, last leaf, and it will fetch record of 13 also. So we will get range query also, isn't it? Nice. So that is actually the application of B plus tree in DBMS. It is very nicely developed for range queries, and also the searching is faster. So it uses the facilities of B tree. Searching is faster. It is a fat tree. It is balanced tree. But range queries are very easily solved. Thank you very much.